And that's usually what I'm trying to convince people to do. Most of the time what I'm trying to convince people to do is just not make it ridiculously slow. What I'm trying to convince people is to go from the 30 seconds one to the 1.3 seconds one.
Right.
And if the 1.3 seconds one, from there, it's like all this like fancy footwork to get it to 300 milliseconds or something like that. We don't need to do that. A big misconception about performance that people have is like the only way you're gonna get good performance is if like you hand rolled all the code in assembly language. It's either I write code in Java and it's horribly slow, or I learn how to hand write assembly language and it's super fast. The bad news is it's not that simple because you need a bunch of knowledge, but the good news is it is that simple if you have the knowledge.
We've got a new episode of the Marco Show with a new guest today. It's a bit interesting since I know who you are, but who are you?
I'm Casey Muratori.
What do you do?
Well, I work on educational materials for performance-oriented software. I mean, or I should say, the idea that programmers should know about performance software and the sort of things that affect the performance of their software. And yeah, I mean, I'm assuming that's why you contacted me for a podcast.
That is true.
But also in my day job, quote unquote, I work on video game development. So
is that how you got into performance? I mean, in general, is that how it all started?
No, actually. And this is something that's a weird aspect of it. I was in the game industry when I started programming way back in the 90s. I'm pretty old now, so this is ancient history. And at that time, I would have been like very much the person who didn't really know anything about performance. And that's stayed true for quite some time. So, when I worked on game stuff, I was usually doing other things. So the super important performance stuff, like working on renderers and things like that, I was usually a little bit above that slice, right? Mm-hmm. So I still, learned a lot about fairly low-level programming by, today's standards, certainly, and working on game engine stuff. But it was... I always would have asked somebody else on the team, right? If you're going to optimize some matrix transform thing that was going on, it's like, that's not going to be Casey's job, right? That's not how that's going to work. Casey does more of the stuff above it, right? So this is one of those things where like certainly the public perception of what I do these days is completely backwards from the history. So nowadays, people like I get called like a performance zealot and things like this.
Yes, yeah.
But actually, like I'm just like mediocre performance. I just want like the regular performance we were getting. And so what happened was sort of maybe in the course of the past 15 years, all the software started getting so bad on the performance front that my like this guy is not really qualified to handle the performance stuff. That became like a high watermark somehow. Like it was like so it's been kind of a little bit bad. It's scary, I guess I say, to watch that happen because people out there don't know, but I know that what I'm talking about is actually not that good.
Which is impossible, to be honest.
But as a result of that, also as I've been doing sort of the focusing on it for the last 2 years and doing sort of specifically educational materials for performance, I have gotten better at it, right? So nowadays, some of the things I talk about, I am more knowledgeable, and so I don't want to make it sound like when I put up some stream that sounds incredibly technical, like that stuff I've more recently learned. Okay, so the me of the past wouldn't necessarily have known that.
Hold on,
so,
I need to call you out on this because I got to know you, let's say, a couple of years ago. Yeah. When you and you need to correct me on this. When you did what I will call the Windows terminal story.
Oh God.
I can tell you from my perspective. So what happened is there was a guy online who turned out to be you, so Casey. You had a stream, you said, or a video and said, well, Windows terminal ran with like 30 frames per second or something like that, 25 frames per second. You tried to cat a large file, a 4 gigabyte file, and you said it should run an order of magnitude faster than that, kind of. And then you went on and I guess implemented or re-implemented parts of the terminal to show how much faster it could be. That's how I got to know you. Okay. Would you mind kind of quickly telling us what happened back then? And yeah,
it's a sore subject, not necessarily with me, but with other people. So I'm happy to tell you what I perceive to have happened, but you have to keep in mind that other people would object. I'm sure. What happened was I was working on some educational materials, and one of the things that I wanted to do in this, I was creating some stuff that was basically for. It was an unreleased thing, so I didn't release this particular set of code that I was working on, but I was trying some things for teaching. And one of the things I wanted to do was give people the ability to start by making, like when they were sort of learning some basics of C, to make something similar to the old school, like when you would print out text in a terminal to play a game. So, back before you necessarily had a graphical display, in the very primitive era of computing, right, compared to what it's like now, you often had these character cell displays or terminals or things like this, literal terminals, and they couldn't necessarily display graphics. A lot of times they couldn't. A VT100, for example, would be a classic terminal that really can't display any graphics. It has only the ability to display character cells. And so you'd have games where it was just character cells, and you'd move a little A around the screen, and there'd be a little slash that represented something. And this was a way that people made games. Some of the earliest games, back in history, right, might have been games that looked like that. So I wanted to allow people to make one of those. And I thought it would be nice if they could select color, if I could show them how to select colors so that when they printed out the A, it could be green or something like that, as opposed to just it being monochrome. And the way that you do that in a terminal is there's these sort of escape codes that you insert, and the terminal, if it's been set in the correct mode, will know to parse those escape sequences and interpret them as instructions to set the color or things like this. So I did that. This is very straightforward, right? Everything I'm saying is very straightforward if you've ever done terminal programming. There's nothing weird here. I'm just doing the basic thing. So I did that, and I noticed that literally trying to play this game that I made that was just, it's a few lines of code. We're talking about 300, 400 lines of code for this thing, most of which is inserting the escape characters. Trying to run it in Windows on the command line, it's running so slowly, right? It's like, oh my God, right? And so I'm like, well, I know there's this Windows terminal thing, which is this new terminal that they're making. And so maybe if I go and get that, that would be better. And then I can just tell the people who are going to be using this courseware that instead of running the standard Windows terminal, if they want, they could just go to the Windows Store and get this one. So does this all make sense so far?
It does.
That's literally what happened. I'm not changing any of that. That's what occurred.
Okay.
I download the Windows terminal, and it's even slower, right? So it's like the already what that was so slow that you waited to move the dude, this one is slower than that. So I'm like, okay, what is going on? I go online and I see that there's GitHub that has the Windows for the Windows terminal. So I post a thing that I'm just extremely slow performance for escape code stuff, and I'm just like, look, here's what's happening. I just posted some simple information. If you send a lot of escape codes, then this thing is just incredibly slow. And I don't want to mischaracterize the response, so just go read the GitHub and you decide for yourself what you think of that thread. Basically what happened was at first, I talked to them, and at first there was some kind of confusion about it, but eventually they were like, yeah, okay, this is kind of a problem, and we'll try to do something about it. Mm-hmm. And I was like, great. And I posted on Twitter, I was like, hey, just wanted to thank, I don't remember, someone from the Windows terminal or something like this. I just wanted to thank them for actually taking a look at this, because I didn't expect them to. I thought they would just be ignored and the issue would go somewhere. It's that's really great. And I did that. Also, in my head, what I was thinking is, if they got some positive PR for agreeing to do this, then that might give them some clearance with their manager. This is literally all the things that I was thinking, and I'm reporting exactly what I did. Right. And then I don't remember the exact thing that caused this to reopen. Because then I was like, okay, great. And maybe it'll happen someday, maybe it won't. But then, for some reason, something happens in the thread. Maybe other people are posting to it or something like this. And one of the Windows terminal people posted that probably this wouldn't be something that they would be able to do for several years or something like this.
It needs a PhD or something like that.
Though that's later.
Okay.
It was something very strange. So I was like, oh, okay, that's unfortunate. And they were because of, this or that, I'm or direct write is too slow. So there's no way that we can really do anything about this. And so it's going to be a really long time. And I said something I'm like, that doesn't make any sense. Like it really doesn't. Like, you know, because in my head, I know how this stuff works. So I'm just like, look, if direct write was slow, you just cache it. Just cache the cells. It's a character cell display. So you could just pre-cache all the cells that you need as they come up, and then you just blit them, right? It's trivial. And, you know, their response to this was so bizarre because I guess I phrased it poorly. I think the only thing I said that was odd was like, what am I missing is what I said, which when I say that, I actually mean it. I'm like, tell me what I'm missing. Right. And I think they obviously must have taken that as being like dismissive or flippant. And so they just like really, I felt it was a very insulting series of replies. Like I read them and I was like, these are some of the most insulting replies I've ever had like posted to me for when I didn't feel like I'd ever like really been aggressive or angry with them, right? You know, sometimes I am aggressive or angry about something online, and then if someone's aggressive or angry back, I'm like, well, that's par for the course, right? It's like that's just how it's gonna go. So after that, I was just like, all right, like screw this, and I just said like, okay, forget everything, and I was like, I just closed it. I didn't really even say anything back. And I think I posted on Twitter, I just posted the thread, I'm like, I don't know what the heck this was supposed to be. Like, this is garbage, right? And I just posted a link to the GitHub. That was the end of it. So, I don't know. You can go read that GitHub and everyone watch this podcast to decide what they think of the series of things that got said in that thing. Could I have been nicer in the things there? I'm sure I could have, but I didn't think I was saying anything particularly weird. But then after that, now I'm just pissed off. Like, after seeing those things, I was just like, totally furious, right? So a really, really excellent programmer, a guy named Martin's Mosaico. He works at Epic now. The company makes Fortnite and the Unreal Engine. If you've ever played a game that's like a AAA game, they made the engine, right? And Martin's is a really amazing programmer. He doesn't do PR. He's not like there's people like me who like go out on the internet and say stuff and whatever, and so people know who they are. But then there's all sorts of programmers who are better than me and better than all the people that you're watching on YouTube. That's just how it is. I'm telling you the truth. You never hear about those guys because they just they're at at their job. They're doing cool stuff, and they don't want a public persona, and they don't do those sorts of things. So he's a really great programmer, and he also, I mean, I don't want to put words in his mouth. I'm sorry, Martins, but I'm like, he also kind of like, he doesn't love it when people are saying like, oh, this thing's gonna be really hard, and he knows that it's not because he's really good. It's obviously not gonna be hard for Martins. So he was just like, okay, you guys don't think you could like render direct write? Like, you think the character cell rendering is the problem here, right? Because, and as we go into this part of the story, it's important to remember, nobody has said anything about the terminal performance. So we're not talking about the performance of the terminal at all. We're talking about the performance of the renderer. So they specifically said that just literally putting the characters on the screen was the bottleneck. So there's nothing they could do to like all their terminal code to speed this up. It's like they don't think that it's possible to put letters on the screen, right? Any faster than what's happening because of how direct write does coloring against backgrounds. I'll spare you the details of that, but if you really want to, we can go into them. So anyway, so Martin's just like, okay, like whatevs. He posts like literally like, I mean, within a day of the stream coming up, a 7,000 frame per second character cell renderer using direct write, right? And it's just doing all these colored like glyphs and backgrounds and all this stuff, right? And so, that was kind of hilarious. So I was just like, all right, what if we just did an actual like basically the terminal shell just without the terminal back part? Could we do it? And so I spent a weekend and I just put that together, right? And it's not like the greatest thing in the world or anything like that. It's pretty basic. But I did like a modified version of his terminal cell renderer. And then he did that part. I did a modified version of that. And I put the like a thing in that would sort of do the basics of terminal. So it would basically accept standard in and standard out. It would accept standard outs, standard errors, and just parse them to the necessary degree to do escape codes and things like this. And that was it. So I posted it, and because I was pissed, I posted a stream that was like, okay, here's like how that worked. so after that, I think this is where the term excuse parade comes from, because I don't think I'd ever said that before, and I don't know. So at this point, this is when like the excuse parade rolls out. So invariably what happens, like if you're someone who knows computers very intimately and you have like a good handle on like how performance works at each stage, then you pretty much know like roughly what kind of performance you're going to get out of something in like a ballpark band. And you don't really know, like, until you really study a problem, you don't really necessarily know like, okay, I'm kind of imagining the peak is like right about here because I'm thinking about all of the different parts of the system and which parts are going to kind of constrain it maximally. So I'm like, the peak will probably be somewhere around here. I know we're not going to hit that, right? Because you never get peak. So it's like, I know we're going to be somewhere in here. And so anything like within 2x of that or something, you would consider, okay, pretty normal or pretty reasonable, and we're not going to worry about it, et cetera, et cetera. So you have like kind of a brain that's working like that. And when you're looking at software, you're kind of making those judgments fairly regularly. But what I find is a lot of people don't really have any awareness of any of that stuff. So what they do to a time, like it's like literally every single time, there's some tranche where people go, if you've shown that something can be faster, like you've literally put out a thing that's much faster than some other thing, they just assume that the only reason is because of something that you did not implement. Now, even if there's no logical way that that thing could possibly cost what this differential, they still believe that. So a classic example of this is there's a program called Rad Debugger, for example. It's a debugger. There's another one called Remedy BG. Both of these debuggers launch instantly. You run them for the command line and they're immediate. Like it just boop, right? And people are like, well, Visual Studio takes like forever to launch. Like if I want to debug something in Visual Studio, I'm sitting around and I'm like, you know. And so when you point out the fact, it's like, well, I can launch these other debuggers immediately, so I should be able to launch Visual Studio's debugger immediately. They're like, well, it's like, but that's in an IDE. So there's no way that like that's the reason. But if like Ryan, the guy who does Rad Debugger, or if George, the guy who does Remedy BG, if they made an IDE, it would also launch instantly. Because there's nothing about the way computers work that requires it to be slower to launch an IDE than a debugger. They're basically the same level of startup necessity. And any of the things that you're thinking of in your head that you think are reasons why, like, oh, it's got a load plugin, all of that stuff can be deferred, right? Like all of that stuff you could have architected. And even if you didn't, all of that still should be fast, right? But invariably, that excuse parade comes out, and that's what the assumption is. So even though we posted basically everything you need to make a terminal, they're still like, well, the fact that I'm not doing like all of a terminal is the reason why this is faster. And it would, instead of being 7,000 frames per second, it would magically drop to 19 if I implemented those things, which is so absurd, but that's where we're at.
Right.
Yeah.
I need to drill down into that point where you said the whole expectation management, because I have to admit, I'm kind of I will call myself a normie. So I did Java programming in the past. I did bank software for BMW, whatever, which is layers on top of, you know, what you just talked about. And I want to give the listener kind of an understanding of what they should be able to expect, even if it's just in an order of magnitude. I read that online on a Minecraft service where people said, well, 1,000 concurrent players on a Minecraft service is crazy, and you couldn't even dream of having multiple thousands because there's no hardware that exists nowadays to support that amount of numbers. Now, when I hear Minecraft servers, I'm not like a game server engineer, whatever, but do you think that 1,000 concurrent players for a video game is insane? Is it low? Is it high? Is it many people, few people? What does that number tell you, kind of, roughly?
So you're talking about I'm running a server for a video game.
Yeah, pretty much.
And people are connecting to this, playing a real-time game on the server.
Yeah.
So I guess what I'd say is there's a couple different things you can think about there in terms of what's going to determine your cap. And this is, I guess, the thing that I was talking about before about understanding those sort of ranges. So there's a number of things which can prevent a server from exceeding a certain number of players. Obviously, one of them is the simulation rate of the game. So when people say something like 1,000 players, is that a lot or a little for a game? You know, is it ridiculous to say we couldn't go past 1,000? The answer is, unfortunately, it depends. And the reason for that is think about what's happening in a video game that you play when you just, you go home and you play something on a PlayStation 5 or whatever. If you looked at what the cost is to run that video game in, the CPU cost, the GPU cost for, running it on this console or however you play games, you're going to have some amount of time that is spent computing like the physics for this game and like the world logic for this game. Now, you're just one player, right? And you're playing the game. If it's a millisecond or 2 milliseconds of total sim time, let's say, that's what it costs. Well, if you want 1,000 of those, now it's 1,000 times 2 milliseconds, right? Now, obviously, when you have a server or something like this, you may be running, I assume the business term for this might be big iron or something like that. So like, a server that's massively more powerful in terms of the number of CPU cores it has. So, maybe you're running it on some computer that has 4 cores or 8 cores normally, whereas you go to a server in the cloud, you can have, we've got this 96 core epic thing, or something like that. And so obviously you get some scaling factor there, but it's only a certain scaling factor. It's not a factor of 1,000. There's no such thing as a 1,000 core server today. AMD, if you are interested in releasing one of those, I would love that. It'd be amazing to program. So you do have to manage some expectations there. Now, so if you were to take a game like that, where we actually knew that the sim time as optimized was something like a millisecond or 2, then yeah, 1,000 players on a server is looking really difficult. How are you going to do that? 2,000 milliseconds is 2 seconds, and that is not real time, right? And et cetera, et cetera, et cetera. So you do have to make sure you understand the problem.
Right.
Now, that's not the same as saying that that all game servers should be excused from only having 10 players on them or something like this. Because there's different levels of work that are involved in simulating the player experience. Because remember, you don't have to do simulation, you have to do the rendering, you have to do the graphics, right? A lot of times you're just talking about the simulation part. So in the past, when we've had things more like massive multiplayer online games, in those, they're often more transactional. So, Minecraft is a real-time game. You move around, there's physics, that sort of thing. So there's a lot more simulation going on. You look at something like maybe a World of Warcraft or, an online game where it's more transactional. And what I mean by that is we're moving around in 3D space. It doesn't really matter. Most of what matters is I chose to cast a spell on this guy. It's a little bit more like playing Magic the Gathering. It's almost like playing a card, right? And when you have a system that's like that, the server doesn't really have to be involved as much. It just has to kind of verify that everything's fine and to make sure that the transactions occur okay. And it's a lot more like a business server than a game server at that point. The client can do a lot of code, can do a lot of the work. And so when I'm moving around the 3D world, most stuff can be happening to the client, not the server, unlike on Minecraft, where it really just has to know those things, right? So when you look back at one of those games, it might be tempting to go like, oh, World of Warcraft could have like 5,000 players in a server or something like that. I mean, I don't know what their peak was, but like, maybe you look back, you see one of those, like they had 5,000 people in a server. Why can't Minecraft do that? It's like, well, it's apples to oranges comparison. So hopefully that gives you a little bit of perspective. I don't want to make a claim about Minecraft because I've never looked at what's entailed in my, I've never played Minecraft.
Me neither.
I tried to play Minecraft. The Microsoft store or the Mojang store, it was after sold to Microsoft. I tried to buy it and it said that like my credit card was not accepted. I still do not know why.
And you fail at that stage? Okay.
I still don't know. I do not know why. This is like, I don't know, what the world's third most valuable company. They could not figure out how to take my credit card. So I still to this day have not played Minecraft. I know that literally everyone in the world plays Minecraft. It's the best selling video game, or one of the best selling video games of all time, and I have never played it. So I still don't know. If someone out there at Microsoft is, if there's anyone at your company who's not mad about the terminal thing, who wants to send me a copy of Minecraft, I'd like to play it, right? I'd like to play that game because everyone in the world has played that game except me because you declined my credit card, and I do not know why. I think I literally bought a game on Steam like 30 minutes after that, and that worked fine. So I'm pretty sure it's not the credit card. But maybe you just didn't want to sell me on. Right. So that's what, right. Yeah. So hopefully, I don't know if that answers the basics of your question, but we can go into more detail on that.
I'm going to bring you into the Java space, actually, just from the game space quickly. Yeah. There was a challenge last year in the Java space. Just to briefly lay it out to you. people said we're going to have a file with 1 billion text rows. Every row had a measurement of a weather station. So it said Hamburg, for example, 20 degrees, Barcelona, 15 degrees, whatever. 1 billion rows. And there was kind of a challenge who made the fastest Java program to read in the file, calculate I think the min, average, and max for every weather station, and print them out on the standard out, essentially. That was it. And at that time, I was doing your performance aware programming course. And I thought, yeah, I mean, it was just the first module available or the second module available. And I thought, could I somehow apply these lessons to that challenge? In any case, people said there were tons of submissions. And I think the fastest submission was roughly 1.5 seconds to read in the file and then print it out and do the min average calculation. Just in general, what do you think about when people read it? They said, well, because let's say the simple submissions were like 30 seconds or 35 seconds, whatever. And then 1.5 seconds was really fast and everyone said that is most amazing, whatever. When you hear these numbers or the text file in general, what would you expect? I mean, in kind of what ballpark that should actually lie, kind of?
So there's a couple of things that I think it's important to mention. So the first one is text files. You can't really say much about text files without specifying exactly what you mean by text files. So I did look at the text file, so now I know what it is. But I want to make sure that I'm clear on this because this is a very important thing for people to understand. So if you have a text file that's like the one in this challenge, that is, for example, a much easier problem for performance than if it was, say, JSON. And the reason for this is the way in which a text file is structured determines a lot about the peak performance that you will be able to get when you parse it. And the reason for that is kind of subtle. The easiest way to think about it is on modern machines, if you really want to max out something like parsing, or really anything, you want to be multi-threaded, right? Anything you want to max out, you probably want multiple threads. And it's possible that the regime in which you're in, you could be in a state where literally just getting the file off of wherever it's coming from could be the bottleneck, in which case this part is not so important. But if we make the assumption that you either, maybe this file is already in memory, like maybe we're not even going to count that part because it got written by something just recently, so it's in the cache, right? Like it's already, not in the cache, in memory rather. It hasn't, when I say cache, it's ambiguous. Not in the CPU cache, but in the memory cache the operating system is using to avoid extraneous file writes or to fulfill them more quickly for reads. So if we assume that we're able to get this thing at like memory bandwidth or something like that, then if we really want to parse it quickly, we want to be able to parse it with multiple cores of your machine at the same time. And if you imagine doing this with a binary file, you will get a linear speed up with CPUs, right? Because each CPU can just take a different chunk of the binary file and off you go. And I should, sorry to keep saying like I should say, I want to be very specific. It's not fair to say binary file. What I mean to say is a file whose format is properly laid out for, parsing. When you look at a text file, if you can't just jump into the middle of the text file and start parsing it, then you're going to force a much slower parse because you can't really use multi-core. So in a JSON file, it's much harder to parallelize parsing the JSON file because you have to be extremely clever about what you're doing. If I start parsing at the top and go to the bottom, I know that I can always just obey standard JSON parsing rules and get a correct parse of the file. If I need to start parsing in the middle because all of my cores are going to have to start at different places, basically, right? So they're each consuming different parts of the file. The core that's starting at the top is fine. It just knows it's doing the right parse. The cores that are starting in somewhere in the middle of the file, right, in different places of the file, they don't know what the status of the parsing would have been at that point. Are they inside a string, right? Or how many levels of brackets were they in, right? So what they have to do is write things that are like best guesses. Like, I'll parse this both as if I'm inside a string at the beginning and if I'm not, or I'll guess which one I am, and then we'll just optimistically parse and throw out this work if it turns out to be wrong, right? So I'm not suggesting that I know the best way to do that because I've never tried that particular problem, but you see what I'm saying? I'm having to think about that right now. And so if you're a performance programmer and you're like, I'm going to tackle this problem, now I've got to have my big boy pants on, right? I'm like, okay, I'm going to work now, right? And this is going to be like weeks of my time figuring out the most clever way to like make these optimal parsers. The other hand, someone throws you a softball like that, where the text is line by line. Now we're loving life. Because I can literally just spread out the threads. Each core starts at an equally distant, I divide the size of the file, I give each core a chunk. And when they start parsing, the definition of those text files it was city name, temperature, return.
Yep.
There is no parser state. All I have to do when I start at some point in the file is look for the next new line and know that I can start parsing normally right at the next character. And off I go, right? So when I get a text file like that, I'm like, I can have baby boy pants on. I don't have to think at all. I'm basically like, I may sandbag it. I might be like, this is going to take at least a month if I'm working at a job I don't like and I'm just there to collect a salary. But if I'm actually like caring about it, right, I'm like, that's done in 15 minutes, right? It's like you just type it in and it's done. As opposed to JSON one where I'm like, oh God, like, okay, here we go. Like, I got to really think about this. I'm going to think about, this is one of those I'm thinking about in the shower, right? Like, what am I going to do? Oh, I can do the thing, right? It's like that kind of problem all of a sudden. So that's really the dichotomy there. And the reason that I was like a little hesitant to say binary versus text before is because it's pretty easy to also define a binary file format for which this is also true. You take something like a Photoshop file, for example. Photoshop files, or, there's a whole lineage of files that go back to this file format from the 1980s. I think it was originally defined by Electronic Arts, called IFF, interchange file format. And these are files that basically they're like data chunked. They basically have like, here's the size, here's a tag, right? And they can have like child blocks, and those can have I don't remember if the original IFF file could have child blocks or not, but the current ones do. So anyway, if you have a binary file like that, you end up in the exact same situation. It's very hard to just start in the middle of the file. Now, oftentimes you could do like still better techniques in text files, because you can at least read and see what the sizes are and then jump directly there and read. But knowing what you're going to be reading off of the drive, so queuing up what the file layout is going to be a little harder still. But you might be able to do something better still than a text file. But you're still in this unfortunate aspect of, I need to read parts of the file to know where else I would be reading in the file. And it complicates your job. It's not the same complex as something that's a real text parse. JSON's, still easier than if I was like doing like something harder. There's even harder versions still of text encoding, so you could be, or text grammars you could be encoding. But you end up in this situation where the file format itself tells you a lot about how hard it is going to be to make this multi-threaded if that's what you wanted. And we can also contemplate binary files that basically are impossible to multi-thread. And that would be something like, let's say, something that's compressed with LZ compression. It's just, the whole thing is back dependent on itself, right? It's like the way those kinds of compressors work is when you're going to read the thing, it's like output these characters. Oh, now go back to what you outputted, copy this much and copy it forward. This, right? If you haven't decompressed the entire file so far, there's nothing you can do to compress the next byte, right? And so it's possible, the reason I was trying to like correct myself when I said binary versus text there, I was giving binary an unfair advantage. I was saying like a binary file that's designed for this. That's not fair. So it's easy for us to pick a binary file that would also have the criteria that this would be either hard or impossible to multi-thread and get a speed win. So that's kind of the layout of that part of the problem. Does that all make reasonable sense? So I'm saying I splatted everything at you there, but that's what's going on.
The issue that I'm now having is that it feels like a really artificial problem.
You're 100% correct.
In terms of, what the Java community focused on was they read 1 billion rows, and they read kind of like, 1 billion rows, like in a second, that's awesome. But the way you're telling it now, it actually, it was kind of a fake, very super simple use case, the way it was laid out. And at the end of the day, yeah.
Well, but that's only the file part. So we're just the file part. So I don't want, So it's important to understand when you create a problem like this, if the problem's created by a performance expert, they're already thinking about these things. And it might have been, right? I don't know. They might have been like, we're going to pick a text file that's like medium hard, right? It's like you still have to, or we're going to pick a file that's medium hard. You still have to parse text, but we will give, it will be relatively easy for you to jump into the middle because we wanted to enable, we didn't want you to have to spend 3 months on this performance challenge, right? So they might, you know, might have been done by a person who was literally knows all the things I just said and was like hitting that middle ground, right? But then we move to the next part of the problem, right? So there's the final part, and that's a part that you then have to go like, all right, I'm gonna have to work out like, you know, roughly how big the file is gonna be. What's the bandwidth gonna be off the SD drive, or if it's coming, or is it coming from memory? I need to know that because that's gonna be my performance cap, because that's the thing there. And then the parsing, like how, you know, am I gonna be able to thread it? In this case, the answer is yes, so that's really good. And so then we move to the actual like computation part. So what I would do on that piece of paper, when I said I need a piece of paper to figure that out, I would be looking at these three chunks. I'd be saying, how do I get the data in? Like, how much multi-threading can I actually get on the like ingress of the data then? And once I have the data, what am I actually going to do in terms of processing it? So what they did in the second part is they said, or the third part rather, what they did is they said, we're going to have the min, average, and max.
Yep.
Now, those are three things that you could compute without having to keep all the data in memory. This is very interesting, right? In other words, you can do those like in blocks. And this is, again, I'm just, because this is a podcast, so you want to talk about performance.
Yeah.
I'm sorry if I'm going on too long.
No, it's perfect.
But I'm trying to give you all of the things that a performance person would think about. A performance person who is as good as me, which, like I said before, is not, you know, so there's a bunch of things that I'm saying here, they're here. And then there's like, there's the upper side. And those people are going to be like, yeah, in case you forgot to mention, no, I'm not making this up. This is not false humility. There will be comments on this when it goes up from a better performance expert who'll be like, yeah, you forgot to say blah. So that's just, I'm telling you what's going to happen.
Okay. There's also going to be 10,000 comments of, you know, Java guys going like, what is going on? But
everyone has their level of expertise, right? Yeah. And if your level of expertise is X in performance, it's down here in something else, right? So everyone has what they're good at, right? So anyway, so there will be people that, so I'm just saying the things that I'm able to think about. So if you look at something like min, max, average, those are all things that can be computed effectively as running sums, right? Or running updates. So every time I get a new answer in, right, I can update what I've got, and they're all able to be managed that way. And moreover, they are non-sequential. So in other words, the minimum, the maximum, and the average are the same no matter what order I give the things in, with the slight caveat that, like, well, floating point computation will not give exactly the same answer potentially, but this did not have, this did not say you needed to be bit accurate in your floating point representation at the end.
It did not.
Right? So it sort of just says, look, any way you compute the average is fine. Min and max will always be the same because that's exact. So you'll get exact answers with those no matter which order you go in, assuming they're all normal floating point numbers and not some weird thing like NaN, right? But the average will also be basically the same. Modulo maybe some bits that are different because of the way floating point works. There could be something like that. I'd have to think through like to what extent that would be true, but you know, but no one would care about that in a human readable form. You're going to get an answer that basically looks the same, right? Now, this is important again, because you therefore can multi-thread the problem again very easily, right? I can just say, compute the min, max, and average on all 32 of my CPU cores of whatever data they saw. And then at the end, I just combine those 32 trivially, right? So again, they've created a problem which has this nice property of no thread communication at all. Right, my threads, my core. I should just use cores. That's what we actually care about. But people don't really think threads, but I usually think cores because that's the actual performance element. So I spin up every core I've got on doing this parse. They each parse their own chunks. They compute their min, max, and averages separately for the data they saw. Then we recombine at the end, and that's our answer, right? So if, for example, the person who made that challenge wanted to be mean, they would have said something like, oh, how about like median? Because now it's like, okay, so I can still do that separated piece. But now when I actually go through these things, I'm going to have to basically keep them all that I did so that I can sort them. And then we're going to have some way of doing this, merging all of our results to find out who's in the middle, right? And so now we're like, okay, we're gonna need like, do we do like some kind of some kind of a 3-stack version of this thing? Do we have like, and at to be honest, since I've never had to do fast median combinations before, I'm now going like, oh, I'm gonna go probably look what the state of the art is in how we recombine medians, and like, because you could probably do something like, well, if I know that this is the median of this set and this is the median of that set, that I don't really need to combine them entirely. I can do this, right? Because I know they're partitioned in this way. So again, you can see just one little change there, and all of a sudden it doesn't necessarily go. It's not like I said, without studying the problem, I'm not necessarily going to say that it would even go slower. Maybe because they'll do it at the same speed for all I know, but it's harder now.
Right.
It's harder to get that speed now. And I'm guessing you probably couldn't get as safe because you're going to have to, it's going to cost you a little bit more, even if you have like a brilliant median combination algorithm, because that's something you work on all the time. So at least in my mind, I'm like, okay, I'm thinking about all these things I go through. I'm like, okay, look at the text files. Like, oh, whew, it's a good text file. Like, I don't have to worry too much for that. Min, max, average. I'm like, yes, like we are loving life. And then we get to the end and they throw us a little bit of curveball. They're like, you gotta print out the results sorted. So I'm like, okay, like you did. Now I've got a thing where I do have to do a little bit more core coordination. Sorting is not something that can happen entirely, separate, but I can still roll into that, so we're having our cores go. At some point, somebody has to produce that master list. But it's not that bad. Why? Because I could everyone can do their own sort of the things they saw. Mm-hmm. And then at the end, we're just kind of merging things that are already sorted. So that last cleanup thread that's going to step in here and just do that last pass over everyone's thing, they don't have that much work to do. It's pretty inexpensive. They're not really resorting anything. They're just walking those lists in order and merging. If the two names are the same, they merge them. If the name isn't the same, they look at the next one. Like, they're just doing a very simple sort of final pass to output the result. So it's still, we're pretty good. So when I look at that problem, I'm like, yeah, it should be pretty fast. But how fast should it be? I need to go run some numbers. I need to think about that thing. Now,
it would be way cool if you ran some numbers at some point and go back. Yeah, but
I wouldn't want to do that on stream, because those are the things that you always check. Right. Yeah. You always check. And I'm like, if I do them on stream, they're going to be wrong. And then the comments are going to be, they're going to be furious with me. Right? They're going to be furious with me for picking the wrong number. So there's all that stuff. And when I looked at that problem briefly before, right, because I sent to me, I think I looked at it like on my phone or something, so I didn't have a chance to really dig into it. But what I noticed was the hardest part of the problem, I think, will end up being the fact that it wants to merge station name. Like, the station names are not unique. Mm-hmm. So every time I encounter a station name, I have to effectively go look up, like I have to find what my current running min-max average is for that station name. This is per core, right? We're just talking about the work the cores are doing. And then fold in whatever the new number I have is to the average and the min-max. And that part, if I had to guess, if getting the data in is not the bottleneck, then that is what I'm guessing will be the bottleneck. I'm guessing the bottleneck will be, how fast can I write a thing that does these lookups? Because if I do that slowly, I think that's going to dominate. If I like something really good that's like a really nice fast lookup for those things, that's probably going to be a hash table. Mm-hmm. Depends on how many station names we expect. I don't know if they listed that. Like, can it be 1 billion?
It can't be 1 billion anymore. It's just a couple of hundred, I think.
If it's a couple hundred, you're in a kind of... Yeah. And do you know what the names are ahead of time or not? Can they be different, or are they always the same names?
Always the same names.
Really?
I think so. Always the same names. I think so.
At that point, you probably can just like know that you've got the right hash. You do the minimum hash table size that like AES, shuffles. If you shuffle the name with AES 3 rounds and you put it in or something, that they don't collide. You just check first that they don't collide, and make it however big it needs to be that they don't collide, and you just go with that. It's probably what you do. So that's really softballing it even more, because there what you're basically what you're telling me is, if you're the client basically, what you're telling me is that I don't have to worry about every name could be unique. So there might be like, right? So you're basically carving off the edge cases, right?
Yep.
Every name could be unique. Or if you're willing to tell me like the names can't be, the whole file is just one long name of a thing, right? The more I know about how restrictive the problem set is, again, the less I'm thinking I'm going to have to think about this in the shower, right?
I want some real numbers from you at some point in the future, but I mean, take your time with them.
Well, maybe is what you're saying that I need to do this as a part of my protocol. Here's what we're going to do, guys.
That'd be awesome. We're
going to see how fast this runs.
I'm going to bring it back to the Java crowd, and then we're gonna see how they react.
Okay.
I want to move.
Maybe we have to do it in Java. This will be my first time ever really programming in Java.
Yes, and Java is, by the way, now getting a really nice extension that you can actually call all the functions you would ever like to call, so SIMD functions, whatever. So we can make it fast. It would be awesome actually to see. It would be awesome to see your solution. To be honest, it would be awesome to see.
Here's what I will say. When I looked at that page, they had the leaderboards there. I felt like it was a pretty good showing, though. Like, when I looked at those numbers, I wasn't depressed. Like you said, 30 seconds was one there. Like, that's depressing, sure. But there were a lot of pretty high numbers up there. Like there was the 1.3 seconds one or whatever. I'm like, what I would say about that is maybe that's not that fast compared to what I will go when I write it down and be like, okay, yeah, maybe it should be 10 times faster or something like that. Maybe that's true. Like, I don't know. I didn't think about it that hard, but whatever. What I will say is it at least wasn't ridiculously slow. And that's usually what I'm trying to convince people to do. Most of the time what I'm trying to convince people to do is just not make it ridiculously slow. What I'm trying to convince people is to go from the 30 seconds one to the 1.3 seconds one.
Right.
And if the 1.3 seconds one, from there, it's like all this like fancy footwork to get it to 300 milliseconds or something like that. We don't need to do that. It's okay. We got the 30x, man. Like, we got that. Like, I just want people to get that cheap 30x that's sitting there by just not doing something stupid, right? And 99% of not doing something stupid is just knowing roughly what has to happen in the computer and making sure you didn't tell your programming language that it has to do something really bad for that computer.
Do you have a rough abstract framework how you would tell anyone how to approach a performance problem, like these 5 steps? It doesn't matter if it's Java, C, whatever. Just follow roughly these couple of things. Know your computer, know your hardware a tiny bit. What would these 5 things be? What would that framework kind of be, if there is any framework?
Well, I mean, since I literally have a performance-aware programming course, if I had a way to tell people just 5 things, what I would do is I would charge a lot more money for it, and it would be about an hour long, right?
By the way, I have to say,
don't have. Oh, sorry.
By the way, I have to say, I've been a paying subscriber for over 2 years for with the Honest course. What's the right word? Honest course, with this course, for this course. It's an insanely good course. Check it out. Subscribe. It's amazing. So sorry. Yeah.
Thank you for the endorsement. But literally, I mean it. Like, if I had a really simple way to do it, I would set a high price tag, and it would be this thing. It would be like one of those like get rich quick schemes, right? But no, like it's really not quite that simple, unfortunately. There's good news and bad news. The bad news is it's not that simple because you need a bunch of knowledge. But the good news is it is that simple if you have the knowledge. Meaning, one of the things I think a big misconception about performance people have is like the only way you're going to get good performance is if like you hand rolled all the code in assembly language. Like it's either I write code in Java and it's horribly slow, or I learn how to handwrite assembly language and it's super fast. And those are my things, right? But that's totally not true. Tons of people write very fast Java code, and tons of people write very slow Java code. In any language that you're in, the big difference is the people writing the fast Java code know what the computer is doing. And they've written their Java program such that they're handing the JIT, or however, if they're doing, I assume you guys do ahead of time compilation in Java now fairly regularly. So in the old days, it was just JIT. But they're handing the JIT or the AOT, whichever one you're using, they're handing it something that they know will turn into nice assembly language code on the other side that the CPU can run cleanly. And they're not hand rolling anything, right? They just know not to set up bad situations. And so most of what you need to be a programmer whose code performs very well is just the knowledge of what the CPU actually is going to do with that code. And by extension, this problem doesn't involve a network. It doesn't involve, other sort of things we might also be talking about. it extends the whole way. So things the CPU needs to do, things the NIC needs to do, things the routers need to do, like whatever it is. If you know what the system has to be doing, it's pretty easy to just give it something it can handle. And if you don't know what the system has to do, right, then it's very likely that you will just pick something totally innocently that is incredibly costly for that system, right? And so when you talk about like what are the 5 things, flipping the good news bad news around, the good news is only one thing. It's that. Be aware of what the system has to do, and your code will just run well. Pretty much. It's unless you're encountering a pathological problem that's a really hard optimization problem, right? You're going to do so. You've decided that the thing that you're going to do is the traveling salesman problem all day on really huge node networks, and you can go attack a hard problem, and then you're in for it, right? But most of the time, we're just doing workaday code. You're writing your business logic code or whatever you're doing. You're not talking about problems that are in that domain. So mostly it's about understanding what is the things that the system has to do and how do you hand it to it in a way that's pretty reasonable. A big part of this, I like to point out as just examples to people. A very simple one would be things that can happen at the same time versus things that have to happen in order. One of the easiest ways that people can make their stuff faster is go, look, if I was doing a set of things in order that really don't have to be done in order, do them at the same time. And the classic example of this is you'll see web pages that take forever to load. You look at why they take forever to load. It's because they do a round trip to the server to get some piece of JavaScript. They run that JavaScript, which needs to go to the route, decides to do a route to the server to get some other piece of JavaScript. And you just go. You get this big old line of people waiting for each other. We call that in performance, we call that a serial dependency chain. It's a chain of dependencies that has to be executed serially. And the browser authors are working overtime. And Cisco is working overtime, and the AWS people are working overtime to try to make those round trips as fast as they can be. But at the end of the day, all you really had to do was go, oh, wait, all of these fetches, I could have queued most of them all at once, and then they all would have overlapped. Yeah. And now I go from a page that took 3 seconds to load to one that loaded in 50 milliseconds, right?
But by the way, AWS is liking it because they bill you, for that overtime.
I shouldn't have said AWS. Sorry. What I should have said is AWS is smiling all the way to the back. Sorry. I want to believe they're trying to optimize this stuff. I mean, are they not? I don't know. Maybe I'm being optimistic. The cost is in the wrong. The cost incentives are wrong, I guess, at some level. They want you to need more servers.
They want you to need more servers.
Okay.
That would have been my next question. See, the thing is now that when I think of the business application I've written in the past, then you don't just deploy them on some bare metal server, whatever, but nowadays everything gets containerized. And then you have maybe 100 containers running on the same machine. And then I don't even know what performance then just means, because at the end of the day, I have 100 containers running somewhere and they get a certain amount of performance, like 1 CPU or 0.5 CPUs. And I, as a programmer, have no idea what is the hardware it's running on. It's containerized like 5 levels up to the sky. There's 20 million other server programs running at the same time. Does that mean I'm lost essentially because there's no way I can figure out how my software can be performant at that stage?
No, actually, it's honestly not a problem at all. So there's two things to keep in mind here, and it's a really nice thing. One thing I'll just say as a meta comment, that programming these days, at least for me, feels fantastic because CPUs and hardware and all this stuff are so good now that I don't really even think about the hardware at that level very often, except when I'm having fun, super optimizing something just because I wanted to or whatever. Normally I write code and it is just blazing fast because these machines are just absolutely amazing, right? So if you follow the advice I said before, it's if you learn how everything works and you're handing things that are easy to compute based on what you know to be true about CPUs and that sort of stuff, it just runs fabulously these days. So the good news about the first part is what I'm going to hand my own machine to run and what I would hand that machine to run in a virtualized container and all this stuff, they're going to both perform the best on roughly the same code. Now, could we tweak each piece of code, changing certain sizes of things, how big our chunks that we operate on are, exactly what kinds of SIMD ops we're doing? Could we clearly make it so that the right code for this one is not the right code for that one? Yes, we can. No question. But we're down, that is down in if you're at that point, you're so much faster than anyone's software that they ship today most of the time. You're in FFmpeg land, the guys who handwrite it, you're in that land, and we wouldn't be having this discussion, right? So when you get to that point, you're in a different playing field. You're on a different playing field, or you're on a different tier, right? The kind of code that I write, the kind of code that you write, we don't have to be really thinking that hard about that. So I think if you learn the basic principles of how to hand computers things that they can process well, it will just work in either scenario. And you will get much faster code in your example as you would if you just ran it on your own machine. The second part of that is actually learning how to do the sort of back of the envelope how to do the back of the envelope computation. Okay. Leave this in because
we're gonna leave it in.
It's been a long week for me. Yeah. I just came from a conference. I was jet lagged. I was probably still jet lagged. Yeah. I was so jet lagged for the first 2 days.
And now asking all these questions.
I've been talking all the time. Yeah. I gave this really long 2-hour lecture on this computer history topic. So my brain is full of crazy facts from 1952. Okay. So being able to pronounce back of the envelope calculation, which is what I tried to say, is actually hard for me right now. So, you cut me some slack. So what I was trying to say is, when I said before, I was referring to performance numbers. If I was going to compute these performance numbers, I have to go get a pen and paper. I want to know what's the speed of the drive, what's the speed of this. Just get some basic numbers here, how fast the CPU, how many cores I got, all that stuff. Do a rough calculation. I'm okay, here's what I might be shooting for peak. I'm not going to get it, but I'd be shooting for peak. So if you can do those kinds of things and you can analyze your code that way, then one of the really nice benefits of that is you can also kind of try and figure out if your cloud provider is screwing you a little bit, right? Because you're if I know what my peak numbers are on various CPUs, I can even collect statistics. There's some pretty cool stuff now. CPUs have great performance metrics. A lot of people don't know about this sort of stuff, but you can collect very good performance metrics from CPUs now. You can run some analysis like that if you know what you're doing. And then you can kind of see they're charging me for this much CPU time. Am I really getting that? They're telling me I have this class of CPU and I know roughly what its metrics should be. I've done my collection metrics over on a similar CPU that I have at home. Maybe I could even run it on the same core type. If they're telling me this is a Zen 4 core, Zen 5 core CPU, what kind of CPU am I talking about? I expect this. I'm hey guys, you billed me this many hours and I only got half that as far as I can tell from my computations here. What's the deal? If I were doing serious work in the cloud, I would be doing that stuff because I'm I want to know I'm getting my money from you guys, right? And it's relatively easy to collect that data these days. It's actually a lot easier than you'd think.
What would I tell programmers to say, well, CPU doesn't matter anyway nowadays anymore because it's all kind of IO bound in the business sphere. You're waiting 5 seconds for the government tax REST service to respond to you. And now don't worry, we know what the CPU has to do. Does that change anything? I mean... It might.
If you don't control all of the sides of the problem, right, then you may be in a situation where, like you said, you said government server, right? So I'm if there's a government server involved... I'm with you. Absolutely. If there's a government server involved, you probably just go home. Just whatever you did, whatever you typed in, whatever you tapped to the AI prompted, and you got some code out of ChatGPT. You pasted it in. It's probably fast enough. I don't know. It's probably fine because the government server is going to be sitting there. It's not going to be up. So why are we even talking about the performance, right? You're gonna send the thing off, and it's not gonna reply. Right. So we don't care how fast our thing was. Infinite long is the answer. But I do want to address sort of maybe a slightly related question to that, because I do think there's a flip side of that I think is again gets into a little bit of excuse making instead of actually grappling with the problem. I do think that there's a bit of an issue where people go they'll say well, the network is super slow, so it doesn't matter what I do on the CPU side, or the database takes a very long time, or things like that. And I think that kind of approach to the problem is bad because it means we are just stuck in a bad performance land permanently. Because if everyone, like, imagine the following hypothetical scenario. I write some very slow client because I just didn't care enough to like actually think it through or something. So I write some very slow client and I run it, and I do bother to check to see what my metrics are, and I find that I'm still waiting on the server anyway most of the time. So I'm just like, well, I don't need to fix this. And then that's the client that I run, we ship it, we're like, hey, yeah, I'm not gonna bother optimizing that because waiting on the server. A month later, some dude's working on the server, and he's like, you know, I wonder if we should optimize some of these queries, right? And they do some tests and they find like, well, you know what? I tried, like, we did some things where we turned up the caching on this one thing to see if it would improve it all. And it turns out we're always waiting on the client. Because, hey, like now you were only slightly fast to the server. The server guys tried it, like, right? So the problem is the mindset of I'm gated on this other thing, right? If that other thing is a real physical limit, like if you're talking about like, well, the fiber ping time between here and there is, you know, the speed of light from here to there is going to be 30 milliseconds. It's like a backhaul thing. Like that's what it is. And you want to say, okay, so then none of our stuff has to run faster than 30 milliseconds. I'm like, you guys sound like my kind of people. I'm right there with you. Do not optimize something that doesn't need to be optimized. If we're already at the speed of light constrained, well, unless you are a really good optimizer, you are not exceeding that, right? But if you are talking about a limit that is artificially imposed, like this database is just kind of slow for some reason, like we're waiting on the database, then the correct attitude is to go find out what the hell is going on with the database, right? Like call up the database people or talk to the database people, find out if there's alternate database you could use, like find out what the heck is going on, because the database should be fast enough to be fulfilling your client requests at a very high speed nowadays. And so what I would say is everyone on every side should be thinking, how do we make this thing go very fast? And until you've gotten up to your, well, literally the network can't go any faster than this, you should be knowing why the problem is. And if you've gotten to the point where you know why the database is slow and you literally can't get anyone to fix it, and for some reason you can't go fix it, then I'm all right. I'm like, okay, you did your best.
Right.
But if you just kind of use that as an excuse to call it quits, then the database people aren't having people ask them to get faster. There's no motivation to go troubleshoot the problem, all that stuff, and then the software just stays slow.
But that's right? Kind of what happens in real life, unfortunately. That is, it cascades and it just gets slower and slower and slower and slower.
Because everyone's using it as an excuse to not know. Like they're using an excuse to not investigate further. Yeah. And so really, and that at the end of the day, it's really it's the intellectual curiosity and investigation that's the biggest problem. Because if everyone was always diving in instead of just going like whatever. And by the way, I don't know that this is not necessarily just a problem with like an individual, right? It's a problem more with a system and an attitude.
Sure.
And like, people bring up management all the time. It's a management problem too. Like, are you encouraging employees to like take, or are you actually discouraging them by not caring? Management can be a huge part of this problem. And you're basically like, you're demotivating people who maybe when they got into programming would have gone and looked at the problem, right?
Yeah, absolutely.
So it's not really assigning blame to anyone in particular. It's sort of more like there's blame everywhere and we could do much better. Everybody could do much better.
I mean, the thing is, when I worked for a bank, for example, I mean, you had, 10 features to build in 2 weeks and performance was not on the horizon. So it's literally just, finish these features. We need to do this and that. And then whoever cares about performance, we didn't care. Yeah.
Yeah.
I never saw people really care about performance.
And how can you in 2 weeks, right? You're just busy like reading this weird spec and trying to go like, wait, what did they mean by this, right? So there's nothing you can do at that point, right? And you're setting people up to deliver a lousy customer experience is what you're doing. And furthermore, you're almost training your developers to deliver a lousy customer experience. You're basically, you're putting them in a situation where they have no choice but to adopt methodologies and work attitudes that are literally going against delivering a high quality customer experience, right? And so, the blame falls on different people at different times, but it's kind of like everywhere in that diffuse way. Like sometimes it's individual people not caring, sometimes it's like management, sometimes it's the whole industry not caring, right?
But just to reiterate, it actually, I mean, the way you said it earlier, it's about performance, let's say, less queries maybe to a database, do stuff in parallel instead of do it sequentially. You don't have to shave off like the last 500 milliseconds or whatever. Just be kind of, I don't know, follow these.
In the ballpark.
In the ballpark.
And this is, again, there's always good news, bad news, right? The bad news is that it's kind of like there's a bit of a pervasive culture of not caring about performance. And again, not just among devs, but all the way up that chain. But the good news is that actually the hardware is so good. And the reason that I keep pointing that out is because, to your point you just said, in the old days, if we were talking about getting great performance, we are talking about things like shaving off those extra cycles, like looking at these loops in assembly language and going, oh, how we figuring out weird tricks in these CPUs to do stuff. None of that has to happen anymore. In order to get very high performance out of modern CPUs, you do not have to touch assembly language. I teach people to read it only. In fact, the performance workhorse, it's to read it only. And it's to learn to read it because that's how you know what the CPU does. I never handwrite assembly language unless I'm testing something, right? I just don't do that. I read it all the time so I can see what my code is actually doing to make sure there's nothing weird going on. I don't handwrite it. In the old days, you want to talk about doing anything at all at a reasonable performance level. Of course, I'm going to have to handwrite assembly language. In fact, one of the reasons we talked about the here, like here's me on performance and then the extras here, that's a good example of that delta. I mean, I don't really even know how to write assembly language at the level I would have needed to know probably back when I was in that position of like, I'm not the performance guy, right? The performance guys were like, they were hand rolling assembly language all the time, right? And so the good news is the bar has moved and the hardware has gotten so much better. And it's not just better. This is another point, and sorry to derail that particular point. It's not just the hardware got better. The hardware got designed for us to have an easier job. CPUs are now like basically hyper optimized to eat, I mean, I'll be honest, bad code. And what that means is that if your code is even just reasonably good, it will just get plowed through by a CPU. It's just like eats it for breakfast because it's trying to run really bad code and you're giving it reasonable code. And it is just like, oh my God, like I can crush this, right? And so that's the really good news is CPUs, because they're now designed basically for bad code in a way. I mean, I'm kind of being a little harsh there, but they're trying to run things that are really not that well, set up for performance. What that means is you've got all this horsepower sitting in the CPU that's going to fix all your little mistakes. So you don't, in fact, they're not even mistakes anymore for that reason. The CPU can just handle it, right? So what would have been a mistake in the past, oh, I ordered these instructions wrong. It doesn't matter anymore. CPU eats them in any order, that it can figure out. And so really, again, it just comes back to that awareness and understanding that you want to give the CPU something reasonable. And when you do, it will absolutely crush your problem because it is set up to handle any small mistakes you make. You do not have to be that kind of a processor anymore. You do not have to be the kind of programmer. You don't have to be like someone who, like a Mike Abrash, or somebody from the old days, that you might have read about, or those people, the people who did hyper optimization. Mike Abrash is the famous graphics programmer who did a lot of hand assembly, wrote the texture mapper in Quake, for example, right? You don't have to be at that level. And that's great news for people like me, right? Because we weren't at that level. And so getting there today is way easier than it used to be.
I like it all the time when you say the level of you kind of, and I'm thinking, dude, I'm on such a different level myself. But anyway,
it's easier than you think. Yeah. This is why I really try to tell. This is why I try to tell that story because it's easier than you think now. And I say that from experience because when I was back in that era, I was not like I could not have written performance code. I'm not making this up. I'm not making this up to make it sound easy as it is. I literally was not good enough at the time to do that. And maybe if I'd had the right training, I could have been. I'm willing to give myself credit. Like I want to believe I'm capable of things. So I want to give myself credit and say, maybe if I'd had the right training or the right mentor to teach me how to approach it, maybe I could have done it, right? And I want to believe that, and maybe that's true. But the real truth of the matter is, like, I did not understand that stuff. I just did not understand it at all. And so nowadays, I think you're in a much better position because you don't have to have that kind of ability and that kind of meticulous ability to focus on such a small problem for such a long time. You don't have to have that ability to write code that is very fast. And so that's what allows me to do things like talk about how to get performance without having to really understand that super crazy thing of like, oh, we're working out the meticulous placement of the instructions and all that sort of thing.
What's your take on, let's say, rewriting stuff for performance reasons? I'll give you an example, because at JetBrains, I'd like to say we pretty much like to write our own stuff. So when we write a product, like in the past, or issue tracker, we thought, hey, it's a great idea to write our own database for our issue tracker. Come to think of it, I think it has kind of bitten us a couple of times then, because you have to maintain it. And then over 10 years, you realize you fall into the same problems, I guess, the challenges that people like Oracle run into with the database product.
Yeah.
Would it ever make sense for someone, a company, to kind of really, these types of products like servers or databases rather, to recreate them from scratch for database reasons? Or would you rather just try and use them as much as possible and try to figure out the best way possible of using them, essentially?
I mean, I think I'm pretty old now, so this is an old person's answer.
How old are you?
I'm 48.
48.
Yeah.
41. So I'm okay.
Okay. You have 7 years before you can start saying you're old. Old is 48. That's what I've decided. So this is an old person's answer to this.
Right.
So take that with a grain of salt.
Right.
So my thinking on this these days is, when you want to decide whether you're going to forget the term rewrite, let's just say take ownership of, like, we're gonna say that this is our code base now, even if we forked it from somewhere, or if we're writing it from scratch to replace something we have, whatever it is. The biggest thing is not will we be able to write it, it's will we be able to maintain it. And the reason for that is it's like cognitive overhead, right? So the way I try to think about these things is, do I want to be maintaining this thing institutionally going forward? Do we want to maintain a database going forward? Is that something we're going to be happy doing? Are we going to have four programmers, 4 devs who are going to want to be doing that at any given time, right? And for me, if the answer is yes, then I'd say, unless you have access to a very high quality solution, like there are some products out there that are very high quality, not many, but there are, right? And so if you have access to one of those, it may still be a hard decision, because you might be like, well, theirs is pretty damn good. Are we that good? I mean, I don't know. Because, projects can fail really easily, and maybe we thought we were really good, and it turns out we weren't so good, right? So it's still a tough call, but otherwise, I think that it really comes down to, do we have people who are really going to take this seriously? And we're going to maintain the resource, and we're going to dedicate ourselves to it. The timing you don't want to do it is just like, well, we'll just rewrite this database and then go back to what we were doing, right? Because that's not going to happen, right? Realistically, it's not going to happen. And the reason it's not going to happen is that even if you are awesome and you write something so baller that it really doesn't need to be maintained in any particular way, and I hope you're that good, because that would be cool. The problem is then you expand somehow. You're like, oh, well, we now need to run that like in the cloud, or we need to run that, on multiple machines, and it was originally just for one machine, and we need to do this, we need to do that. And you keep getting pulled back into the project, right? And so again, it's really about, do you have people who are going to commit to be doing that and that want to do that? In a way, it's almost like, treat it like an enlightened life decision you were going to make, right? Like an enlightened life decision is like, I need to, I need to know whether I really like playing music. I really like playing guitar, and it's really like my passion or whatever. That's something that I can't play guitar. This is a hypothetical situation. But like I have this good job at a bank or whatever, and like, do I want to go, like, I have this opportunity to tour with the band, but it's not going to pay very well or whatever, but I've always wanted to do that, and or do I stay at the bank where I know it's a thing and whatever, right? And you've got all these things to weigh. At the end of the day, you have to think about, it's like, look, time is the only non-renewable resource. I have to think about, in 10 years, in 20 years, I'm going to look back and I say, what did I spend my time on? And honestly, with programming, even if it's at a job, even if it's at a job you don't like that much, it's sort of a similar decision where it's like, I'm going to have to look back over this 10 years and say, was I doing something I want? And if the answer to you is, I'm psyched about spending that 10 years doing this like issue database or whatever. Like I love database stuff and I want to work on it. And I'm going to keep, and anytime there's a new challenge on a database, I'm psyched. If you're thinking that in your head, then like, go for it, man. Like that's probably going to succeed actually to a large extent. Yeah. If what you're thinking is like, I want to be working on the other, like, I don't know what else is in JetBrains, but I want to be working on like, semantic analysis of code. Like I want to be doing stuff that's like, flagging errors. I'm really into that sort of stuff and parsing or whatever it is. That's what I want to be doing. But the issue tracker sucks. And like Dave quit and he was the person supposed to be doing the database integration. So I'll just go over there and write, like, don't do that. Yeah. Because what that's going to do is going to make you miserable. I mean, make miserable, you write bad code. Bad code makes bad product makes an unhappy world, right? So I would treat it like that. I'd treat it like you have the opportunity to go tour with the band or whatever it is. Like, which one's touring with the band for you, right? Or which one's working at the bank if you're a person who plays it conservative. And you were like, no, I wouldn't go tour with the band. It's like, I have a wife and kids. I care about the job. Use that part of your brain.
It's a great answer.
You know what I mean?
Yeah.
And so that's what I would say. Yeah. And I think that that's probably the only way to approach those things. So there's so much uncertainty in a decision like that. There's no perfect way to approach it. Yes. You're gonna have to think through like, what do you want this company to look like, and what do you want your devs to be like? What will make people happy to be working?
I need to get in touch with some of our devs because they would love the discussion. Anyway, we'll do that later.
Okay. When I fly, you offered to take me for sausage and pretzels and mustard and Munich.
Yes, mustard. Yes, we can do it. And there will be a ton of devs who would love to talk with you.
Okay.
To move on a tiny bit, everyone's darling. What do you think of AI? Have you played with AI? Have you played with LLMs? Anything like that?
So there's three primary things that I think about with AI. And I'll save the one that I think is sort of the most disturbing for me as the third one. So the first one is a positive thing, which is I like the fact that we've finally gotten to a place where we can sort of get English to be relatively well parsed by a computer. Parsed and understood for some Turing test version of understood. Like obviously the computer might not really be understanding, quote unquote, in the same way that a human is understanding the language, but it's certainly enough that if we compare it to the other kinds of problems we solve with computers, we've sort of gotten to what I would consider a solution. And this was a very long-standing problem in computer science or linguistics, depending on how you want to break that down. And so I am very happy to see that people have figured out something that at least for some domains, under some circumstances, is clearly able to understand English at the level that it can do things we would want it to do, and we would consider the problem solved slowly. These things are very expensive, unfortunately, but it can do them to a level that I thought I'd be like, that is really cool. We finally got a real solution to this that doesn't really seem to be asterisk anywhere, where it's like, well, it kind of understands English, like not really. It's like, no, it's like this thing, because the humans don't understand English a lot of times too, right? And I shouldn't just say English. That's the language I speak, so I think about
language.
But it's, as far as I can tell, it's pretty good at most human languages. Yes. So it's not just English either. It's not hyper specialized.
And also mix-ups like we call it Denglish, so German English. So we can just whatever any.
It seems to be able to process English in a similar way that a human might parse the input, right? And so that it tends to exhibit similar sorts of understanding to us. Now, I have seen a lot of like pathological ways that people can sort of find. So it's not perfect, right? Because an artifact of the design is such that it's not really operating on first-hand knowledge the way we are. So it's coming in from a disadvantage. It only knows about the world's third hand, right? Kind of, it has to have someone who experienced something, who wrote about it, who then the AI inputted it, right? And it's so it's having to construct this fantasy world through weights, essentially, that it uses to reason. And so its reasoning is not the same as our reasoning as a result, even no matter how good we push it. there's that problem. And so, to order to get the one that really understands our language, maybe it has to be a robot that goes through and learns about the world by doing things, maybe that has to happen. I don't know. But very long-winded answer, but to the thing about that first point, I do like that we've solved that, or at least had our first real thing we could call a solution. All the previous things I would not really call them a solution. I call them kind of hacks, even no matter how good they really were. So there's that. Thing number 2 is AI in my domain, so programming. I'm not interested in AI in my domain pretty much at all. And the reason for that is there isn't really anything that AI does in my domain that interests me. What I mean by that is there's 2 sorts of things you might be doing when you're programming. That might be reductive, but for this purpose of this answer. One is you might be programming because you have a particular end result that you wish to achieve. I can understand why people are interested in AI if that is what they were doing when they're programming. Because if you can find a way to use the AI to get to that endpoint faster, that's a plus.
Give me that CSS. Yes, exactly.
Right? And in that case, especially if you don't like the thing. And CSS. You will get no disagreement from me. But when you're talking about that aspect of it, the only real concerns I have with that, on that prong, are that currently AI produces really lousy output from my perspective, right? It is, I'm trying to convince people to do performance stuff, right? And that sort of thing. And the stuff that the AI code outputs is the kind of stuff it learned on GitHub, which is pretty bad, right? So I'm a little concerned about that aspect, but oh well, right? I mean, that's the thing. And then the answer to that is like, if I were a security researcher, I would be even more concerned because I'm like, if you were training this thing on code from GitHub, it's like, that's just riddled with security exploits. So I'm concerned about the quality aspects of the AI code. And I'm concerned about the fact that they're adopting this as a workflow prior to the AIs getting good enough to avoid these like performance issues, stability issues, reliability issues, security issues. That concerns me because I care about software quality. And so even if you are someone who's just trying to get some end result out of your programming, adopting the AI is like at this stage feels not like what I want. Now that problem may be solved by AI companies. If they can produce over the next 5-10 years, they can keep refining these guys. Maybe they get to the level that I would consider a good programmer. Then we don't have that problem. Okay. So there's that prong, but I don't care about that. What I do when I program is learn. That is what I like about programming. I don't really care about like whether or not the end product is a particular thing. It's like, I don't really care about the Machiavellian aspect of it. It's not like the end justifies the means. So like AI put in there. I want to learn what the best way is to do the thing that I'm doing and push sort of the state of the art of that thing forward. Like I want to go like, what's the best way to structure this code? Oh, you know what? That wasn't the best way. What about this? Right. Like, what are the problems? And so if the AI does something for me, I don't really learn anything. And it's possible that I could imagine a workflow with AI where I did learn things where it's maybe like I'm having it generate a piece of code for me that I'm going to look at or something like that. But as far as I can think of, like typing isn't a bottleneck for me. So at least as far as I can think of, me understanding the code takes the same, like I could have just written it in the same amount of time that the AI would do it and then I would read it. So I don't see what the benefit is if I have to understand the thing. So to me, the AI just doesn't really offer anything because it's really, to go back to the guitar metaphor, it's like if you had someone who was really loved to play the guitar and like to get better at playing the guitar and you're like, why don't you use AI to do the guitar? It's like, well, because I am playing the guitar. I didn't play guitar because I wanted to have a track of guitar and that was the only thing I wanted. I wanted to play the guitar, right? And so when you think about it that way, AI is just kind of, it will always be useless to me. Like I physically can't get what I want out of programming if an AI is involved because literally what the AI is doing is it's robbing me of the experience that I wanted to have and the knowledge that I wanted to get. And so I might be able to use AI in other aspects of my life, right? Generate a transcript for this podcast that I can read. Sure. And that's a benefit to me. I didn't want to be a transcriber, right? But programming, it's kind of just useless to me.
It's an interesting way of putting it, to say it robs you of the experience you wanted to have.
Yes.
Because that is actually it. I guess that many programmers would like to be robbed for whatever reason, because they just have the Machiavellian aspect and just want to get done with it.
Yes.
And you might be a unique, individual kind of, but at the end of the day, I think,
not unique, because I've met many people who are that way, right? It's I do think it splits people. It splits the community in half, though. Yeah. Probably not in half. It splits the community into two groups. Yeah. There are people who program because there's something that needs to be programmed, and they are just going to. Their idea of programming is that we're trying to get that done, and if they could just magically not do it, that would be almost good for them. They'd be like, yeah, I just want the thing. I don't want to or I just want to get my job done, right? And then there's people who just love to program. And for them, I just don't see, AI just can't really help you, because you're not programming when you're using it. You're doing a different activity. Now, there will be a third prong. It's probably already happened, but there'll be a third prong eventually if there isn't. And that's people who love to use AI to code, which is a third thing entirely, right? And that's someone who enjoys the act of prompting the AI to get things. So you could also love the activity, but the activity is prompting. And that's a weird thing to me. I can't relate. But then again, there's tons of people who can't relate to me loving programming. They're like, you want to stare at all these symbols on the screen and move them around. And it's just what's wrong with you, right? And then there's a compiler that comes in all the time and tells you did it wrong. It's syntax error, whatever. It's no, don't worry. It's just helping me catch a thing. So
can I get a video of you vibe coding? Just you prompting the LLM. It would be a great stream.
Well, there is a stream of so the Primogen, right? I often do streams with him. I'm on a podcast with him called The Stand Up as well, that we do every week. So I like hanging out with those guys, and he tried an experiment where he had his Twitch chat would type in prompts for the AI, and they prompted it to make a little game. The quote unquote game. It's not really playable, but it's a thing that approximates a game, that was an old Wolfenstein 3D, like a ray casting engine kind of game, right? And he walked me through the code. He's like, what do you think of it, right? And it's not me vibe coding, but the code was it was so bad. I was like, oh my God, this is awful. So I'm guessing that me vibe coding would just be shaking my head, just oh my God, why is the AI doing this? What did it do? How do I tell it not to do that? Yeah. So that's what I'm assuming it would be, but maybe I would just have a really easy time conversing with it and be like, no, please don't do the thing. Make sure you always if you're going to compute the distance, compute it in a function first, and then use that function. Don't compute the distance by hand in every spot. That's what I wanted to type to the thing. I don't know if it would understand that exactly, but that's what I would type. So anyway.
How do you think kids nowadays are supposed to learn though? Because they're going to go to uni. They're going to have ChatGPT. They're going to go the quick route, I guess. A lot of them are going to go.
Yeah.
How are they gonna end up in that segment of yours where they're just, I don't know, curious and they want to have the experience and not take the shortcut towards?
So one of the things about it is, let's just talk about being fortunate for a second. I was incredibly, incredibly fortunate in life that the thing that I really loved doing also happened to be something that pays well, right? Because that means that I got to go to work every day and do something that I absolutely loved doing. Now, it literally is just good fortune, because I hate to keep bringing up the car metaphor, but I figured, why use multiple metaphors when I can just use one, and it so far has been usable every single time. So we're just going to go with it and not make people have to hold multiple different metaphorical contexts in their head to understand this conversation. So if I had really loved playing guitar, I would not have had that fortunate experience, right? The people who get paid very well to play guitar are few and far between. It's like winning the rock star lottery or something like that. even if I was exceptional at it, there are people who are fantastic at guitar. I mean, I literally have seen people who are absolutely magnificent at playing that instrument by any objective measure and barely make ends meet. Because that is just the reality. The society does not pay an outsized price to the music industry. They do to a small tranche of rock stars, but everybody else, no matter how good you are at your instrument, not the case. And so if that had been me, then I would have probably been poor. That's just the reality of the situation, right? Maybe I would have got lucky and been a studio musician or something like that and made an okay living. Maybe I would get super lucky and be a rock star, but both of those things are fairly unlikely. Having been born loving programming, it was almost a shoo-in that I was going to be paid well. Because you can be, I'll be completely honest with you, you can be really crappy at programming and get paid very well in this world.
It's true.
That's just...
It is true.
Right?
It is true.
So it's okay with me on a practical level, like just being honest with myself and the world. It's okay with me on a practical level if basically I have to understand that the world will shift to one where people like me will be poor in the future. Not just because I was lucky enough to get it first, but because I understand that that was just a lucky accident for me. And I can't expect the entire world to be structured to make that not to make that always be true. You know, I would love if I had the magic wand, I would wave it, because obviously being me and having had that experience, I would love it that other people like me will have the ability to make a good living doing the thing they love. But at the end of the day, that's a selfish thing to expect from the world, right? It's basically saying that I expect all of society to organize itself so that my particular chosen profession, because I love it, is the one that will keep getting all the money. So I do think that if the world is shifting to one that doesn't value programming time, because AIs are mostly doing it, then to answer your question in the way that I've answered all your questions, it says that 30 minutes later, after talking about how the earth cooled and then we crawled out of the primordial soup and then, the DNA and all this stuff, right? But, I do remember the question and I'm always trying to honestly answer it. At the end there, if that's the way society is shifting, then that just means that people like me will be like people who love guitar now. Maybe we do have to have a job at a bank that won't necessarily be the job, but I'm just saying whatever the job is that you're imagining, I have to go to work today and I'll come home and play guitar. And honestly, like if that's the way it shifted in 10 years or 20 years, then what I would do is I'll put out a free course called like How to Love Programming. And it'll just be for those people who want to program as their hobby, right? Because I think the bottom line is you don't really need people to play guitar anymore. Right? Because the public, sadly, and I wish this wasn't true, the public will happily listen to a pop song that just had like a guitar synth put into it, right? And I wish that wasn't the case because I love hearing a real guitarist play. There's a project we're working on now that it's not announced, but let's just say that we used all real musicians for it. So I put my money where our mouth is and my company's mouth is on that one.
Right.
But the truth is society doesn't care that much, as we just said, doesn't care enough. And so it's like, if that's the way it's going to go, then that's okay with me. And it just means that like, it's not as good as it was for me, but I would still want to support those people and say, I'm going to make this fun thing so that you can learn to play guitar at home and have fun playing guitar. Only for me, it's like typing into the computer at home in the old way that you used to do it. And so I think that spirit can be kept alive basically forever in the same way that guitar has been kept alive. And the fact that, and you can go on Instagram right now and see kids who are amazing guitarists and they're learning, they know full well you can get a plugin that will do guitar stuff on a song. Like they know that, but a human being picks up a guitar and they hear it. And some of us go like, I don't know, I can't do this. And some of you just go like, oh yeah, that was great. And like, oh, I love the sound of it. Oh, like teach me more, right? And that was me for computers and a whole bunch of other people for computers. And I think those people will always be here. What will go away is this huge sort of pressure to generate this gigantic swath of 20 million people now, I guess, who are doing programming 19 million of which don't even like it, right? Right?
Yeah, it's kind of like that. Yeah, true.
And that part won't really be bad because they didn't like it anyway. Yeah. And so for them, it was just a job. And whatever the other job is, I hope we'll still have jobs. So like, I don't know, whoever you are, the optimist, whatever it is, whatever the T1000, whatever you're doing, please don't take away all the jobs because I'm going to need one. Like we're all going to need one. Maybe I'll be dead.
You're going to write the course. I mean, for the other people, essentially
right, there you go. Yeah, so, but they need to have a job to pay me.
True.
For that course. Yeah. So anyway, I'll have to research for free because no one will have any money. So I won't make any money either. But yeah. So, you know, at that point, it will be okay that the 19 million people who didn't like programming anyway they're going to go do another job that they didn't like anyway, right? So that's just having to have a job, which is okay. I mean, like, if I have to have a job I don't like, I mean, I've certainly done things for jobs that I didn't like, right? So if I have to have a job occasionally I didn't like, that's okay. And that's just how it'll be. Mm-hmm. So, but then, yeah, the only sad part is it's a remorseful that's like, it was cool that for a while, for people who love to program, you got paid really well. Mm-hmm. That was great, right? It was fun while it lasted, is what I would say. So do you want to go to the third prong yet, or do you want to
go to the third one, yeah.
Third prong this is the part where I actively am very anti-AI and very upset about it. And that is the theft part of it. Mm. So in my opinion, if you were just talking about a research AI, and it goes and it crawls all these things that are other people's copyright and just ingests them all and does whatever, if it's just research, and you did it and you figured it out and you're like, oh, hey, we did this research, that's cool. That's one thing. If you're talking about allocating massive amounts of societal resources, because the spend on AI is like nothing I've ever seen before, right? We're talking like hundreds of billions of dollars, right? It is absurd. I mean, it's more than hundreds of billions is probably undervaluing what it's going to end up being, right? Trillions of dollars, I don't know.
Yeah.
You're talking about a massive spend of societal resources. And so what that means is some of it is going into the actual physical hardware, like literal physical hardware costs, where we talk about, we're taking sand out of the ground, we're turning it into silicon ingots, we're like doing this thing, we're imaging on it, we're cutting those into chips, we're putting on things, slapping on the memory, like all that stuff, right? Yeah. So some of that is literal like production cost, but a large amount of it is actually just going to people.
Yeah.
It's paying AI developers huge salaries. It's paying people at NVIDIA to design hardware huge salaries. It's like a lot of it's going to people and also to founders or VCs who will get cash outs when these companies become public or where they get bought. All of that money, the thing that the AI people did is like 0.1% of the work. Because the vast majority of the work in AI is the input. Without that input, there is nothing. And AI like literally can't do anything without all of the training data. The rest of society made your training data, and you are paying them
nothing
of that $1 trillion.
Nothing.
Now, it's an open legal question as to what extent that is or is not fair use and things like that. There's a whole bunch legal sides of things we get into. But the moral side of that is unambiguous. It's absolutely disgusting. So I find that, honestly, I find it reprehensible. And the reason for that is because if you look, historically speaking, at sort of the behavior of the kinds of people who are now doing this AI stuff, this is the same industry that falls all over itself to be up on the latest, like, we're good for society kinds of stuff, right? It's like, oh, what are we doing about climate change or Black Lives Matter or whatever the thing is that is currently happening as a political issue. They are falling all over themselves to try to convince you that they are a good person. Right? So they're not just going like, oh yeah, we don't care about any of these societal movements or whatever they are. We don't care about that. We're companies. What we do is we make money and we make products. That's what we do, right? No. Like they are, and this is like CEOs posting this stuff on Twitter. We're not talking about the PR department. We're talking about they're putting themselves out there as personally being invested in. I saw a video by Apple where they had like Mother Earth come to visit their headquarters. Have you seen this?
I haven't.
And they were so proud of the fact that their like Apple Watch is like carbon neutral or something like this, right? Like things like that, right? If you're that person and you are not paying all of the artists who you took their work to feed into the AI, you're not paying all the coders whose code you scraped off GitHub. Yep. You're not paying all the writers.
Stack Overflow, yeah.
If you're not giving them 75% of your funding round back to them, or 80%, because they did 99% of the work and you did 1, right? Yeah. you are unethical. Like when you go home, you should not be sleeping well at night and thinking you're a good person, because you're not. Now, you don't have to be a good person. That's not a rule in this world, right? I mean, God knows.
Yeah.
But like, there is no amount of you donating to a charity or being climate conscious or anything like that will ever make up for that theft of other people's work that you did without asking them even, right? This is not like underpaying an employee.
Yeah, absolutely.
This is just straight up theft. So yeah, you can cut this part of the podcast if you don't want to be controversial, but that's my honest opinion about it.
We're going to put it in. And I feel like we could go on for hours and hours about that topic alone.
Yeah, I think I've said the explosive part of it, so there you go. Yeah.
I feel like we have to slowly wrap it up. But by the way, I saw a post about Stack Overflow a couple of weeks ago where they posted where they showed stats how many messages are being created on Stack Overflow nowadays. And now it's like the same as 2009 when they were created. So it effectively went dead, which is, I mean, and it's exactly that topic.
It's just not, it's not acceptable. It's not the way you should behave in society if you actually want to be an ethical person. And I mean, history is filled with exploitation, but I wanted people to be better than that.
Right, yeah.
That's the way I listen. Yeah. I was hoping that they were, but they're not.
Yeah. I've got a couple of silly questions at the end.
Hit me.
Mac, Linux, Windows.
I have spent my entire career developing on Windows, and I actually, my complaints aside, because you always complain about the operating system you use, I was always a relatively happy Windows user in the fact that I never really considered switching to anything else because, it works pretty well and does things I want. It's a good environment for developing game stuff. As of this year, 50% of the computers we run are now Linux.
Right.
And I am looking to move that to 100% over the next few years if I can. And the reason for that has been the direction that Microsoft has decided to go with their operating system is just becoming unbearable. I don't want toast pop-ups telling me I should try the Xbox Game Pass. I don't want ads in my start bar. I don't want Windows Update running whenever it damn well feels like. I don't want my UI constantly getting slower because you rewrote it in God knows what, React.js. I don't even know what they wrote. I haven't looked, but I don't want it to keep getting worse. It is absolutely controlled flight into terrain. They had something that if they just kept shipping Windows 7, I probably would have used it forever, but they are actively driving me off the platform, and I don't think I'm alone. I mean, we're in an era where PewDiePie, one of the biggest streamers in history was like, let's do Linux, right? Or something like that, running Arch Linux, right? It feels like it's in the air that Windows is in trouble. And I'm like, I'm feeling that too. Right. So I was a happy, I was a not going to switch Windows user, let's say. And now I think I might end up being a primarily Linux user over the next 5 years, realistically.
Next one, IDEs. And you don't have to say JetBrains IDE. So IDEs, Vim, Emacs, Notepad. What's your favorite choice of coding?
So I use a custom-made editor, text editor. And I don't really use an IDE per se. So you don't have to worry about me endorsing a competitor. I don't use one. So I use a debugger called RemedyBG, and Rad Debugger is the other one, which I'm slowly switching over to, but I was always used RemedyBG in the past. So I'm imagining my custom editor would be paired with the Rad Debugger probably is what I'll be using, on any given day.
Right. If you could delete one programming language from existence, which one dies? And how much faster does the world become?
Python.
Okay. I'm waiting for the comments because we've got lots of Python users.
So the reason for that is because I don't really want to pick on Python specifically. It's just because it's so widely adopted, right? There are plenty of languages that have the same kind of issues as Python does, but Python had the misfortune of becoming very popular, so that's why I'm deleting it, right? In this magical world, right? It wasn't anything against Python personally. There have been many bad languages, right? So Python is not alone; it's not uniquely bad. It's mostly that it's hugely adopted, and just, honestly, I've never really looked into it that closely because I always have so much stuff to do. Just, I didn't have time to look at it just out of curiosity. I don't know what it is that makes Python so impenetrable in terms of people trying to make reasonably performant versions of it. I would have expected by now with so much Python code, and I'm just guessing it must be something to do with like, some choices they made and how the language makes it just impossible to JIT this thing well or something like that. But for some reason, it seems like we're still at a place where the normal usage of Python is still going through an interpreter. I mean, correct me if I'm wrong about that, but like, and I just assumed that by now that we go, of course not. I mean, so many people write code about it. How is that possible? It seems to be the case. And like I said, I haven't looked into it. I'm sure it'd be very interesting. Maybe sometime when I'm done with this particular course I'm making now, I'll do a little series on like, let's see why Python can't be accelerated just out of the box or whatever, right? And so that's really the problem with it, because something like JavaScript, right? It's at least JITable, and they've done some pretty good jobs. Like you can write some fairly fast code that runs in JavaScript. Actually, it's not going to be fantastic, but it's not going to be Python, right? And so for whatever reason, Python is in this nasty state where it doesn't seem to be able to be accelerated in the way that I would have expected by now. And so again, I don't want to say it too hardly because maybe, I don't know if it's just, I'm imagining people have looked at this so many, there's so much money in that probably, right? I mean, people have looked at this certainly, but somehow it's not getting fixed. So I don't know. So I'm not educated about that area, so I can't comment on it. But it's like, the reason I would delete it is because somehow it's still getting interpreted. We're still getting interpreted code in 2025. Like, what is happening, right? And Python is the reason, because no one else is using, and no other interpreted languages really have the same level of foothold. So that would be it. So I apologize. It's nothing against Python users. It really isn't. You should. I would like it if you guys could have a compiled language. I don't know why you don't have one. I don't want you to stop programming Python. I just want Python to be faster, but I guess it can't be. I don't know.
2 last questions. If you could force one company to rewrite their bloated software from scratch, which would it be and why? Do you have any particular piece of software in mind which you would like to see rewritten? Anything that comes to mind?
So I guess that question, I have to ask a clarifying question. Is rewriting their bloated software from scratch mean that they will literally be taking the exact specification for the software and just re-implementing it with a much better version? Or does it mean rewriting the entire thing, including like its interface substrate, so that the whole thing is now designed for performance?
You choose. Maybe just the first one to keep it somewhat, I don't know, practical, I guess.
Okay. Because the answer to the second one's easy. That's the browser. Because it makes all of us have to write bad software because of the way, like basically the spec for how, basically the platform definition is bad, right? But if I can't do that, because then rewriting the browser wouldn't help, because the browser's already written pretty well. People have spent a lot of time making those run recently. There's only so much they can do based on the spec. In terms of just rewriting the internals of something, because like I said, like something like Windows, it's these ancillary decisions. The kernel is just fine, right? Is there a piece of software?
If there's nothing, I mean, we can, think about it maybe then next week. If something comes up, just send it to me and we'll just...
That's a really tough one. I'm trying to think if there is some software, like, it would have been something like Visual Studio before I had, like, when Remedy BG came out, that was huge for me. Because that was like, oh, now I can have a really fast, good debugger again, right? Because before I'd use Visual Studio, it's really slow and kind of bloated. So there, I might have had an answer to that back at a different time, but I've kind of migrated away from the source software. Oh, I've got one.
Go ahead.
Photoshop.
Okay.
Or I'll throw here for you guys. Premiere. Right. Okay. One of those like video, because there's a lot of like trying to use those packages sometimes is really mind numbing. Like we tried to make something in After Effects one time and I was shocked at how slow it was. But anyway, so maybe the Adobe Creative Cloud, that would be high on the list. That'd be high on the list. Yeah.
We have to stop with we have to close with something self-humbling, I guess. What's the most embarrassing performance bug you've ever shipped, if any? Or let's say,
most embarrassing performance bug. I don't know. Well, so I don't know if this is embarrassing or not, but I can tell I can tell a like lack of knowledge performance story, right? One of the problems about performance bugs, or I shouldn't say performance bugs, but like lack of performance is often it's not from like a bug per se. It's like because you didn't know how to write something. So like most of the things that I made before 2005 or something, right, are all not written like probably as well as they should be for that reason, period. I would say like I worked on a game called The Witness, and I did like the movement system for it. And I remember doing some performance optimizations on that. And I thought I was doing a really good job at the time. And it runs well. Like this is why I say it's not that embarrassing, because like I didn't ship something that was like really crappy or anything like that. But thinking back now to like the optimization I did on it, I'm like, yeah, that was not like S tier stuff at all. Like I'm like, like this could have been so much simpler than I made it, and it could have been so much faster, and like it was not good. In terms of an embarrassing performance bug, I can't think of anything exactly. Like I'm sorry I don't have one of those. I mean, I'm embarrassed that I ship my stuff on Substack right now because Substack is horribly ill performant. I just can't access their code. Right. Yeah. You know, so that's pretty embarrassing for me too. But
and by the way, to your point, I mean, I've looked at every piece of code I've written over the past 10 years, and I'm just like slightly embarrassed all the time. You know how bad it was, kind of.
Yes, I'm kind of glad that people can't see it sometimes. You know, I'm just like, it's not great. Like if we're honest about it, right? Like, but on the other hand, the positive way to spin that is, the more embarrassed you are about your old code, the more it means you improved.
Yep,
right?
True.
So I can at least look back at it and say like, okay, yes, that was embarrassing. Like I hope no one goes and looks at that witness code because they're going to be like, wait, this guy teaches a performance course? Yeah. Moron, right? Like, but it's like, okay, yes, but I got better, right? I you know? And so I do think we can at least say like, okay, well, it means you got better, and that's something positive, right?
We're also running a giveaway, by the way, for a 1-year license for any of our products or a coupon for our merch store.
And what you need to do is you need to describe how you make this very important life decision, okay? You have 2 possible life paths. You can work a stable job at the bank and know that you'll be able to provide for your eventual family if you have one, et cetera, et cetera. Or you follow your passion of going out on the road on tour with a band to play guitar, and you don't know if that will go anywhere. Maybe it will be something that turns into a career. Maybe you will just be a starving artist who's on the road all the time and you never get to see your wife and kids, et cetera, et cetera. Or I guess I should make this gender neutral. So your wife and kids or your husband and kids, right? So which one's it going to be, right? And how are you going to decide?
On that note, folks, we're wrapping up. If in 10 years' time we're all out of jobs, Casey will still be writing his course, so you need to follow his course in 10 years' time. Yeah,
there you
go. He will be there
if you have a job.
Otherwise,
it'll just be free.
If you have a job or whatever. But you could actually, I don't know, go cooking, whatever, and then we just put the price on a reasonable level, and you will be able to follow the arcane ways of writing software. Yes. At some point,
we'll barter for it. Yeah, well, I'll trade you the course materials for like one leather raw hide or something like that.
That's
that
what
I can use for tanning.
So and I'm quite good at cooking, so I might have to cook you something,
Perfect. We've got a deal.
We're going to work that out.
I love it.
Thank you, Casey. Thank you for the talk. It was a pleasure.
Thank you for inviting me, and thank you for coming to Stockholm.
Yeah, sure.
It's been a real pleasure, and I loved being guest on your podcast.